Let's get started on your notes over solving a system of equations using the substitution method. So what's another word for substitute? Replace. That's what a lot of students think of, replace. So we're going to be replacing variables with expressions that equal the same thing. So the steps that we're going to take to solve using the substitution method, the first thing we're going to do is solve for one variable in one equation. Now that means you could either solve for x equals some expression that you'll get, or y equals some expression that you get. But you get either variable by itself on one side of the equal sign. The next thing you're going to do is substitute the expression into the other equation. Now when we're going through these examples, I'll refer back to these steps so that you get a better idea of what they mean. The next thing we're going to do is you've now created one equation with one variable. When you have one equation and one variable, then you can solve for the value of that variable. And that's what you're going to do, solve for the value of that variable. And then the last thing you're going to do, you've solved for the value of one variable. Well, then you're going to substitute that value into any of the other equations that you have. And solve for the value of the other variable. So let's look at number one. The first thing we're going to do is solve for one variable in one equation. Well, what do you see here? I already have one variable solved for, so I don't need to rearrange an equation and get one variable all by itself. I already have that here. The step two says substitute the expression into the other equation. Okay, this is really a difficult concept for students. So if x equals y plus 5, anywhere I see x, I can replace it with y plus 5. So I see x right here. Now I'm going to write this off to the side. Instead of 3x plus 4y equals negative 6, I'm going to write 3 and then I'm going to replace x with something. So when I do that, I replace it with parentheses. And then what am I replacing x with? Y plus 5. So instead of 3 times x, I'm going to write 3 times y plus 5. And if you look at that step 3, you've now created one equation with one variable. I only have the variable y in this equation. Now I can solve for the value of the variable. Distribute the 3 into each term inside the parentheses. So 3y plus 15 plus 4y equals negative 6, and now I need to combine like terms. 3y and 4y is 7y, plus 15 equals negative 6, and now I'm going to subtract 15, and I get 7y equals negative 21. If I'm going too fast, all I did, subtract 15, that removed it from that side, and then I got negative 21. Negative 6 minus 15 is negative 21. And now I need to divide by 7. So I get y equals negative 3. If I'm solving that equation too fast for you, pause the video and write your steps in between. Some students really like to show I'm dividing by 7. Okay, so now I get y equals negative 3. This is the value of your y variable. Okay. This is the solution, okay? That's the y value. So now what you're going to do, we're now at step 4. You've now solved for the value of one variable. We're going to take that value and substitute into any one of these equations. So if y equals negative 3, anywhere I see y, I can replace it with negative 3, which means I can replace it in this equation or this equation and solve for the value of x. Which one would you choose? It doesn't matter. I would choose this one right here, right? X equals y plus 5, which means x equals negative 3 plus 5, which means x equals 2. So now we have our x and y values for our solution, right? This is the point of intersection. If we were to take these two equations and graph them on the coordinate plane, this would be the point of intersection, and that's 2, negative 3. Remember, we write our ordered pairs, x comma y. So let's move on to number 2. Number 2, we're going to solve for one variable in one equation. Well, what do you notice? Y is already solved for here. I could also solve for x here. That would be fine. I really like this problem because we're going to be using fractions. And don't be afraid of fractions, especially if you have a calculator. But if y equals 1/2 x minus 1, anywhere I see y, I can replace it with 1/2 x minus 1. I see y right here. So instead of x plus y, it's going to be x plus 1/2 x minus 1. Now, if there were a minus sign there, I would put parentheses here, but there's a plus right here, so I didn't put parentheses. If you did, it's fine. It won't change anything. Equals 5. Okay, so now what do we need to do? We need to combine like terms. Okay, so I have an x and then I have a fraction in front of that x value. Well, when I'm adding, I know I need common denominators. So what I'm going to do here, this is really 1x, which is 1 over 1. Right here, that's 1x. Well, if I want to add it to 1/2 x, could I rewrite this as 2 over 2 times x? And then when I'm combining like terms, right here, I've got 2 over 2 plus 1 over 2, which is 3 over 2. You could also write 1.5, but we're going to write 3 over 2 times x minus 1 equals 5. And now what do I need to do? Add 1. 3/2 x equals 6. And now I'm solving for the variable, and I've got a fraction as a coefficient. So what do? I multiply by the reciprocal. 2 over 3, what I do to one side, I have to do to the other. So now I'm multiplying by 2/3. 2/3 of 6 is 4. So x equals 4. And if you need to use your calculator, you can. So now we have our x value. How do I determine the y value? Anywhere I see x, I can replace it with 4 or substitute it. I see x right here. I also see x right here. I can plug it into either equation, it doesn't matter, and solve for the value of y. I'm going to plug it in this top one since y is already solved for. So instead of 1/2 times x, I'm going to write 1/2 times 4 minus 1. What's half of 4? 2. 2 minus 1 is 1, and now I have my x and y values, and I'm going to write them as an ordered pair, which is 4, 1. Now be careful when you're taking a quiz or a test, and the question says, what is the x value of the solution to this system of equations? Well, what is the x value? It's 4. What is the y value of the solution to this system of equations? It's 1. So just be careful about questions like that. Looking at number 3. So I know my first step is to solve for one variable in one equation. Is there an equation where I could solve for a variable and it would be really easy to solve for a variable? Actually, either one. I could solve for y by subtracting 2x here. I could solve for x here by adding 2y. I'm going to solve for x in this second equation. By doing that, I'm going to rewrite it. X equals, I'm adding 2y to both sides. That's how I'm doing this. And I get x equals 2y plus 1. Okay, so I've solved for one variable. Okay, I've got one variable all by itself on one side of the equal sign. So now if x equals 2y plus 1, anywhere I see x, boom, I can replace it with 2y plus 1. So instead of, in this first equation right here, instead of 2 times x plus y, I'm going to replace that x with parentheses. Everything else, I'm going to write like that. And then what am I replacing x with? 2y plus 1. Now I've got one equation, one variable, and I can solve for the value of y. What do I do first? Distribute this 2. So I get 4y plus 2 plus y equals 2. And now what do? Combine like terms. 4y plus y, 5y plus 2 is 2. And now I'm going to subtract 2 from both sides, and I'm going to actually show you this part. 5y equals 0, and I really want to show you this because a lot of students mess up with this. I encourage you to solve this all the way out because now I'm dividing by 5. 0 divided by 5 is what? 0. Okay, a lot of students want to say no solution on problems like this, but this is 0. So I encourage you to solve it all the way through. It is okay to have 0 in your numerator. It is okay. All right, it is not okay to have 0 in your denominator. That is not okay. That's when it would be undefined. So this is 0. So now I have the value of y. How do I solve for the value of x? Anywhere I see y, I can replace it with 0. I see y right here. I see y right here. I also see y right there. Which one would you replace y with 0? I would do this one where x is already solved for. So instead of x equals 2 times y, x equals 2 times 0, which means x equals 1. How do you write your solution? 1, 0. Let's move along. We've got 3 more examples. I'm going to try to pick up the pace a little bit. Number 4. Number 4, I need to solve for the value, or I need to get one variable all by itself on one side of the equal sign. Well, I already have y right here, already solved for. So since y is already solved for in one equation, I'm just going to leave it, and if y equals 1/2 x minus 1, anywhere I see y, ding, 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 I can replace it with 1/2 x minus 1. So I'm going to rewrite this top equation. X minus 2 times, I'm going to replace y with what y equals, which is 1/2 times x minus 1. And don't forget to write the rest of that equation. This equals 2. Okay, I'm going to erase some of this because there's a lot going on. Okay. And now what do I need to do? I need to distribute this -2 into each term on the inside of the parentheses. So x minus, what's half of 2? It's 1. So x minus 1x, and I'm just going to write it as a coefficient. You don't have to write that 1. The -2 times -1 is +2 equals 2. And now, wait a second here, what's going on? If I don't see any coefficient, anything in front of a variable, what can I put there? 1. So now if I'm combining like terms, what's 1x minus 1x? 0. They cancel. And now I'm left with 2 equals 2. Okay, well, what do we know when we get rid of our variables and we end up with a statement that is true? This is a true statement. When you get rid of your variables and you end up with a true statement, what's your answer? Infinitely many solutions. So that is the answer to number 4. Infinitely many solutions. And you can write infinitely many solutions. You can write that infinity symbol. Doesn't matter, that's fine. Let's go on to number 5. Okay, so what would you do? What's the first step? Solve for the value of a variable, or solve for a variable. Everything else on the other side, we've already got that in this equation right here. If x equals y minus 3, anywhere I see x, I can replace it with y minus 3. So I'm going to rewrite that top equation. 3y equals not 2 times x, but 2 times what x equals, which is y minus 3, then plus 4. And now I'm just going to solve. I've got one variable, one equation, and now I can solve for the value of that variable. I'm going to distribute this 2. So 3y equals 2y minus 6 plus 4. Combine like terms. 3y equals 2y, -6 and +4, -2. And now I need to move my variables to one side. So minus 2y, and I get y equals -2. And I'm done solving for the value of one variable. I need the value of the other variable. So if y equals -2, anywhere I see y in any equation, I can replace it with -2. Some of you might want to choose this equation. I have no idea why. because in this equation, x is already solved for. It'd be much easier to replace y with negative 2 in that second equation. So x equals negative 2 minus 3, which means x equals negative 5. Let's write our answer as an ordered pair. Negative 5, negative 2. What's the x value of the solution to this system of equations? Negative 5. What's the y value of the solution to the system of equations? Negative 2. Let's move on to our last example. Number 6. Okay, y equals 4x minus 1, and then y minus 2 equals 4x. We've already got one equation with a variable already all by itself on one side of the equal sign. Awesome, first step is done. If y equals 4x minus 1, anywhere I see 4x minus 1, I can replace it. I can replace y. Oh, did I say that right? Anywhere I see y, I can replace it with 4x minus 1. So I'm actually going to highlight this one. Oh gosh, is that not going to let me? Okay, never mind. Not going to highlight. We're not going to do that. So 4x minus 1, I'm going to replace y with 4x minus 1 because it equals the same thing. And I'm going to rewrite the rest of this equation. Okay, I'm only replacing y with 4x minus 1. This minus 2 equals 4x, that stays there. So now let's solve. I've got one equation, one variable, let's solve. The first thing I'm going to do is combine like terms, and I get 4x minus 3 equals 4x. Well, let's get our variables to one side. In doing that, I'm going to subtract 4x, and I get negative 3 equals 4x minus 4x is 0. Okay, well, we've gotten rid of our variables, and we're ending up with a statement that is not true. Negative 3 does not equal 0. This is not a true statement. When we get rid of our variables and we end up with a statement that is not true, what's our answer? No solution. That is our answer. And that concludes your notes over solving a system of equations using the substitution method. This method is typically pretty confusing for Algebra 1 students early on, so if you're struggling with it a little bit, you've got a lot of people that are in the same boat as you, so good luck.